In this video, we will see an example about a waiting line. In the slides and also in the book, you can see these formulas. These formulas are for a queuing system or for a waiting line system in which the arrivals follow a Poisson process, or in other words, we can say that inter-arrival times are exponentially distributed. The rate for the arrival is denoted by lambda, here, lambda. And then we have exponentially distributed service times with parameter mu or rate mu. And we have one server. So for this queuing system, we can calculate the performance measures as you can see in this table. So we can calculate the utilization level, the average time spent in the system and also in the line. Note the difference between the average time spent in the system and also in the line. So when we talk about the time in the system, we are talking about the time that has spent waiting and also in the line, and also the time that has been spent in the service during the service. And then for the time in the line, we only consider the time that has been spent for waiting, and we will not include the time for the service. So performance measures can be calculated as you can see in this table. We can also calculate the average number of customers in the system and also the average number of customers that are waiting in the line. We will use these formulas to solve the example that we will see in the next slide. This is about the same company that we talked about in the break-even point example. So we have a hotline with one server, with one person that will work 24 hours a day. The service rates are 15 calls per hour, and then the arrival rate of the calls are 11 calls per hour. And we want to calculate the average number of customers waiting to be served. There is also a policy that says that the waiting time, the average waiting time of the customers should not exceed 2.5 minutes. And what we want to see if this requirement is met in the current system or not. So to calculate the average number of customers waiting to be served, waiting in the line, we need to use the formula CW for CW. So here we know lambda is equal to 11 and mu is equal to 15. And then if we substitute these numbers into this formula, we'll get 2.017 as the average number of customers waiting to be served. Then to see if the time requirement is met or not, we need to calculate the average waiting time for a customer. So we'll use the formula for TW. Again, we know lambda, which is equal to 11, and mu, which is equal to 15. So if we substitute these numbers into this formula, we'll get a average waiting time equal to 0.183. Our time units were hours, so this is the average waiting time in hours. We can translate it to the minutes, so it will be about 11 minutes. So based on this average waiting time that we have calculated using the formulas, we can say that the time requirement, that 2.5 minutes, are not satisfied in the current system. I have tried to simulate the first more than 1,000 customers that arrive to this system. So you are familiar with these simulation models. I am using exponentially distributed service times and exponentially distributed inter-arrival times here. And the parameters that I'm using are 15 and 11 as described in the example. And I do this simulation for 200 replications for first 1,000 of customers that arrive to our system. And here we can see the results. If we calculate the average time in the system using the formula, we'll get 11 for the average time, which was the number that we calculated in the slides. And we can also calculate the number of customers or the calls in the system, which is equal to 2.875. You can do the calculations and see and check this number. But if we do the simulation, then we will get these numbers from the simulation. And you can see that these numbers are very close to the numbers that are got from the formulas. So for the average waiting time here in this realization of the number, I have 10.76, and then for the average number in the system, I have 2.71. And if I press F9, so I can see that the numbers are changing around the same values that are calculated based on the formulas. Here what you can do is to change the service rate and arrival rate and see how they will affect the performance measures you have calculated in your simulation. One may expect that if you decrease the service rate and approach the arrival rate, then both the average waiting time in the system and also the average numbers in the system, the average number of calls in the system will increase. So try that at home and see how these numbers are changing.